Yes. All right, so we're on 1C.11 part 3, and we're introducing what's called the binomial theorem and Pascal's triangle. Pascal's triangle. So, binomial theorem and Pascal's triangle. Okay. So when writing out the binomial expression a plus b to any power, right? N can be a positive number. The pattern known as Pascal's triangle appears, as well as other interesting facts to be discovered. So basically, this person sat down, realized, oh my God, there's a pattern here. Big wonder. Math is full of patterns? You don't say. Okay. And they realized that they could use this to help multiply larger factors quicker. Okay. To start off with, though, we're going to define the binomial coefficient. So if you look right here, it says the expression, parentheses, in R, read as n above R, is called a binomial coefficient. Okay. When you see a binomial coefficient in above R, this is the operation that you're following. So does anyone know what an exclamation mark means in mathematics? Yeah. Emphasis. No, it's not emphasis. Not fractions. It just means that you're multiplying every integer that followed before it. Every whole number. So for example, if I add 5, yay! Okay, no, 5 isn't excited. What this means, it's a factorial. It means that I'm actually doing 5 times 4 times 3 times 2 times 1. No, it just stops at 1. Only your whole number, your positive integers only.
If you multiply it by 0,
so instead of writing it all the way out up to those numbers, you just write 5 factorial. Okay.
when does that ever need to be finished?
So that
So if n is equal, so if n equals 7,
Yeah.
so it's 7 times 6,
You-
that's 5 times.
all the way down. Okay. It's more commonly used in statistics than any other algebra-based course. However, for us, for pre-cal, it is used when you're doing the binomial coefficient. It is how the formula is set up. So for binomial coefficient, you're n above R or n over R, however your teacher says it. But n factorial divided by R factorial times n minus R factorial. What this? Yes, factorial. The factor, the excited mark. Yeah. The exclamation mark. It's the excited mark, didn't I? You know what I meant. It is called a factorial. Okay. So we're going to practice following this rule and using the factorial.
If that equation n equals 10 and R equals 4, then it would be for the n minus R, it would be 6 times 5 times 4 times 2.
Yep. All right. Are you ready to do an example with it?
Negative.
It won't be.
So it won't be like that?
Yeah.
Yeah, it's not in
The N and R, you're going to do the insight first and then apply the exclamation mark.
So like,
PEMDAS still applies. Yeah. All right. So we're going to do exactly. You see the excitement? Yeah. You get it? No? Okay. Because of the exclamation mark. Yeah. All right. So we're going to do an example. So we're going to find the binomial coefficient, and we have 6 over 2. So the binomial coefficient for 6 over 2. So to set it up, this is our n, this is our r. Agree? N, r, and the rule that we're following is n factorial. So 6 over r factorial times n minus r factorial.
I can do this, like, I don't really think I like it.
Okay, so now we're going to clean it up. So we have 6 factorial. Oh, thank you. No, I've had it since 2005. I don't need to hear that. Didn't need to hear that at all. Thank you. Again, didn't need to hear that. I don't know why we're still quoting how old we are compared to how long I've had my phone. Look here, guys.
Not too much.
The message has been received. God. Does that make y'all feel better?
That was for the Bushman's thing.
All right. So now we have 6. No, we're not yelling the numbers. So the goal is before we multiply is to simplify. All right. The fastest way to simplify is just kind of thinking about, I'm not going to write all this out. I'm not going to write the whole 6 times 5 times 4 times 3 times 2 times 1, right? But in theory, if this is on the non-calculator, then no. But in theory, you should be able to see that if I have 6, 5, 4, 3, 2, 1 in the denominator, in the numerator, and I have 2, 1, 4, 5, 3, 2, 1, do you see what's going to cancel out? Yes, no, maybe so.
Yes, I see it.
What would cancel out?
2.
We would cancel out a 4. Okay, so I'm going to write it out then.
We'll cancel out 4, 3, 2, 1.
So I'm going to expand it. So we have 6, 5, 4, 3, 2, 1 in the numerator. Agree? Then we have 2, 1, 4, 3, 2, 1 in the denominator. These are all, this cancels, 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 this cancels. Yes? Because I didn't have room and I was trying to tell you to visualize, but visualization wasn't happening.
It's because.
Oh, wait, because the 2 is already X. It's, okay.
Yeah. So do we see what will cancel out? You don't, it canceled out. We repeated it. We wrote it. 6 minus 2 gave us 4. And 4 factorial is 4, 3, 2, 1, right? 2 factorial is 2, 1, 6. So these would cancel out. Yeah. And all you're left with is 30 over 2, which equals what? So your leading coefficient would be a 15. Okay. All right, let's try it again. And we're going to do it without expanding. Is that cool? Okay, we're going to do it without expanding. So writing it out first. This is going to be 9. Yay! 9 factorial. Over 4 factorial times 5 factorial. Okay, so in the bottom, what is our largest factorial that we have? 5. So that means if I only write the 9, the 8, the 7, and the 6, my 5 factorial is going to do what? It's going to cancel out. Does that make sense? Because these are going to cancel out. So even if because I would write 5, 4, 3, 2, 1, 5, 4, 3, 2, 1, and they're going to go away. Is there any reason for me to do that if I can just see that they're going to cancel out? I don't need to write it. It's just wasting my time. So now you're just going to multiply. You either can reduce and multiply or multiply then reduce. You only go to 1. If you go to 0, what happens, Randy? It goes to 0. I think you can multiply out loud. Ready? What's 9 times 8? 72. Do y'all want to know a shortcut? Are y'all good with number sense? If this is on the calculator part, you could, Hudson. No. 4 pi, 4 factorial is 4, 3, 2, and 1. 4 and 2 make what? 8. Yeah. 4 and 2 makes 8. So guess what I just eliminated? 8. 3 can make my 6 and 2a. 2. So that also is gone. And now I just have left 9 times 7. What's 9 times 7? 80. 63, right? Our little fingers. Right? Where am I? Yeah, little finger count. Okay. And then 63 times 2 is what? 126. Okay, so let's do it again. Yep. So here, we got rid of 8 because 4 times 2 is 8. We got rid of 3 because 6 divided by 3 is 2. Now we just multiply. 9 times 7 is 63. 63 times 2 is 126. Look at us not using a calculator and just using our number skills. Yes, here.
We went long way.
You can do it however you want. On C, I want you to do it really quick. One.
Oh man, let's see.
All right, do C.
I got you.
I think it's one.
Oh,
Wait,
yeah.
no, you have to expand.
So what's the answer to the?
One twenty-six over 126 over nothing. Okay, next.
Yeah. Oh, yeah. I understand that.
Then just put 0.
I'm shaking my head.
Okay.
So what did y'all get? One.
You just told me to say 0.
I thought you were talking about like in the bottom.
You was trying to trick us.
I wasn't. So you have 3 factorial over 3 factorial, and then you have 0 factorial.
Never trick us.
0 factorial equals 1. This is just a 1. And anything divided by itself is 1. So all we're left with is 1.
Yay. Wait, how do you get 0?
3 minus 3. The formula is your n minus your r. Right?
Oh,
I don't want to.
All right. How do we feel about a binomial coefficient?
Like binomial theorem.
Yeah,
It's not very cool.
it's not very cool. It wasn't exciting. No? Okay.
this is so easy until.
But doable. Yes? All right. So are we good to go on? On to next. Next, we're going to talk about Pascal's triangle. All right. So Pascal's triangle can be used to find the values of your binomial coefficients in expanding expressions. So you know how when we FOIL, right? FOIL, we would have, if I had x plus 1 squared, we would use FOIL to expand it, right? If I had x plus 1 to the third, we would FOIL and distribute, right? X plus 1 to the fourth, well, that starts to get a little tedious, right? And so someone realized that there's a pattern taking place every single time you expand, okay? That pattern that takes place is called Pascal's triangle, and it's part of your binomial expansion. So, for example, for Pascal's, when you're creating it, it is starting off with 1. So row 0 is our 1. That's just one term, a coefficient hanging out up there, right? Next, you're going to have row 1. Row 1 is where our 1s begin. It's going to always be 1s down along the sides. And then you're adding these together to make the next term. Does that make sense? Yes. So 1 plus 1 made 2. So on row 2, we now have 1, 2, and 1. Okay, now we're on to row 3. So row 3, 1 plus 2 makes 3. And then 2 plus 1 makes 3. And that makes row 3. Then it keeps going on to row 4. 1 plus 3 makes 3 plus 3 makes 3 plus 1 makes, and then it keeps going. So this would be our row 4, row 5, row 6, and it just keeps going. Do we understand how the triangle is growing?
The ones on the outside.
The 1s are always on the outside. Yes? Are we good? Okay. Yeah, so we're going to apply that to this. So we have x plus y to the 0. Well, anything to the 0 power is what? 1. That's why row 0 is 1, because anything to the 0 power is 1. Next, x plus 1 to the y. That just means that your coefficients on your variables are just going to be 1 and 1, because that's row 1, 1 and 1. Yes? All right, moving on. X plus y squared, which is our normal binomial that we factored using FOIL, correct? When I have x plus y squared, what am I doing mathematically? Well, if I go look at row 2, it tells me that my coefficient is 1. The coefficient of my middle term is 2. The coefficient of my last term is 1. And I'm going to follow the pattern of x squared plus 2xy plus y squared, which is what we normally would have.
Did you say the middle one has to be 2? Oh,
The coefficient has to be 2.
x squared, y squared. 1. If the left and the right on Pascal's triangle are 1, wouldn't it just be x?
Because you're on row 2 is telling you your power of your leading term. So my leading term is 2, right? And that's just because if I was to distribute with FOIL, x squared is going to be what? Squared, correct? Yeah, x squared is going to be squared. Yes. So it's telling you your coefficients of your terms. No, there's a pattern to the powers. So when you're counting the powers, your powers are going to be if I'm going from 2, that means that this x2, x's are decreasing as my y's are increasing. So x squared, 1x, 1y, y squared. Yes. Yes, that's right. Okay, same thing here. So x plus y to the third. So our coefficients are 1, 3, 3, and 1. Agree? Okay, now we're going to focus on the powers of our variables. So our x's are going to be decreasing as our y's are increasing to get to 3. So we start off with x cubed, x squared, 1x, right? This one, we start off with 1y, y to the 1, y squared, y to the third. And that's because your first terms are decreasing and your second terms are increasing. Because you know that your ends have to be the same power. Yeah? Okay. Are we ready to just try it? I hope so too. Let's dive in. Okay. So this is what explaining what I just told you. All right. So if you're trying to find the exact value of your coefficient, that's where the binomial coefficient comes into play. So if you look right here, notice your n is your power, correct? And then you're going to have your coefficients from there. So we have n0. So starting at first one with just n, it's going to be n over 0. Then we have n over 1, n over 2, and then it keeps going until all of your n has been satisfied. That's where that binomial coefficient comes into play. Okay, so if I'm asking you what is the third term of my quadratic, or not my quadratic, our quartic function. The third term would be n over 2 because the first one starts at 0. So 0, 1, 2, and then I would have 4 over 2 and figure out what that would be. And that would be my third term coefficient. Yes? Yes, it would take you longer to just factor it all out. If all else fails, could you just multiply everything out? Yes. However, when y'all did that, I gave y'all that little bonus of number 10 on the test. Most of you did not get that right because you didn't realize I could just multiply things out. Because I gave y'all a preview of this as number 10 on the bonus on our Unit 1B test. And yeah, you did not. Not everyone just multiplied it out. So that's okay. But let's just do an example. See how it goes. Sometimes seeing it out makes it better. Cool? All right, so we're going to do x minus 2 to the third. This is where we're going to start. Okay, because it's to the third, we know we're on the third row of Pascal's triangle, correct? So the third row of Pascal's triangle is 1, 3, 3, and 1. So I know that this is going to have how many terms? 4. It's going to have 4 terms in my polynomial expansion. Agree? For those terms, the coefficients are 1 or multiples of 1, 3, 3, and 1. Agree? Okay, next we're going to start off with our x and y powers. So you're going to be manipulating those all the way down. So starting off with here, x, I like to do it in parts just to show you. So we know our first coefficient is 1. For x, we're going to have x to the third. Our next term is a negative 2, correct? So for negative 2, it's going to be negative 2 to the 0. Because we're building up. So our first term is decreasing. Our second term is increasing in power. Okay?
Okay.
Our first term is decreasing in power. Our second term is increasing in power. Still with me?
Yeah.
Okay, so next we're going to have plus 3. But now, instead of x to the third, it's going to be x squared. Instead of -2 to the 0, it's going to be -2 to the 1. And we keep going. Plus 3. And again, x's are decreasing. There you go. Mhm. Now we're at the last one. There's our last coefficient is what though? It's a 1. So we're 1 and we're x to the 0, -2 to the 3rd. That's it. And then you clean it up.
Oh, okay, I see it. Here's the question. I see the third.
Don't ask it. Don't ask it.
No, it's not about P.
Oh, okay.
Can you memorize this? Or is it gonna be on a?
You need to memorize Pascal's triangle. So
Well, like all of, like,
the rule, you just got to remember the rule. The rule is that the first term's powers are decreasing. The second term's powers are increasing. That's all you have to remember. I mean, but seeing it, was it that bad? Huh. Okay. Okay. I will start over. I am. Here we go. We're going to hear it a second time. Okay. But this is the easiest it's going to get. So I want to make sure we're at the easy, we're comfortable. Does that make sense? All right. First thing we're going to do is look at the power of our factor. What is the power of my factor? 3. So because my power of my factor is 3, I'm going to go to Pascal's triangle, and I know that my coefficients are going to be factors, multiples of 1, 3, 3, and 1. Agree? So that's the rule that we're following. We're following 1, 3, 3, and 1. Yeah? Okay, so we started off 1, and I'm going to do it in different colors to highlight. My first term is x. Your first term is going to be decreasing in power. So it starts off as 3. My second term is -2. And it's going to be increasing in power. Yes?
What do you mean by decreasing?
Huh?
What do you mean by decreasing?
0, 1, 2, 3. 3, 2, 1, 0. This is gonna always start. This starts with whatever the power is of the factor. This is gonna always start at 0. Your first term, this is a term. Terms are things that are being added or subtracted together, right? So the value of my first term, its power is going to be decreasing. This is my second term. The value of my second term is the power of my second term is going to be increasing. No, it's just the rule. It's going to increase till you get to the other end of it.
So it's increasing, but it's always going to be 0.
So
This starts 0, 1, 2, 3. This number is increasing. Not the term isn't changing. The power is increasing. This power is decreasing. This power is increasing. Yes, Jacob. If they stay together. So if this had been 2x, then it would have been parentheses 2x to the 3rd.
what power are you talking about?
Yeah. They stay together.
No, that's for the x.
Okay. All right. So then I keep going. So following that, my next is going to be plus 3. This time we have x to the 2. And then we have -2 to the 1. Then we have plus 3. And we have x to the 1. Then we have -2 to the 2. And then x to the 0. And then we have -2 to the 3rd. Yeah. Do we see it? Did the colors help?
No, it didn't really help. I just lost.
Okay. But at some point, there's a click. Okay. And now we simplify it. So you now do the math to simplify. Okay. So we're just going to math it out. Okay. So here we have 1 times x to the 3rd times 1, because anything to the 0 power is 1. That's just going to be x to the 3rd. Agree? 1 times x to the third times 1 is just x to the third. On the next one, we have 3 times -2, which makes -6, and then x squared. I'm intentionally putting the plus just so that we can. Okay, now we have -2 squared. What is -2 squared? 4. What is 4 times 3? That gives us 12x. And then we have 1 times 1, which is 1. And then we have -2 to the third, which is what? -8. So therefore, this is x to the third minus 6x squared plus 12x minus 8. No, I did not. I took out my plus signs. Thank you. Huh? Those are, yes, it's just the spacing.
Yeah.
Yes. All right. Do you guys want to? No? All right. Here we go. So expand 2x minus 3 to the 4th. So which level of Pascals are we at? So we're doing 1, 4, 6, 4, 1. Agree? If you think so.
Well, both ways are right.
I thought math was like easy.
This is what they deemed was easier than having 4 factors being multiplied.
Grab your calculator.
Yeah, why like we can't use calculators? Okay,
Listen, we have this conversation on a weekly basis.
you said we use Desmos.
On parts of the test, the test is not all calculator. I don't have time to keep telling you that. Majority of your test is non-calculator. That's how it's set up. Pre-calculus. You are the calculator. Okay, so the expanding using Pascal's triangle and the binomial theorem, we're doing 1, 4, 6, 4, 1. If for whatever reason that's not clicking for you, do you still have the Algebra 2 foundation of multiplying binomials in multiple distribution? In theory, you should, right? Yes? Yeah? All right, so I'm going to do Pascal's and binomial expansion. If you would like to go back old school and see what happens, go for it. My work and your work will not match. All right.
Oh, I'm not foiling all that.
That's your other option. Okay, that's your other option. All right, so we're going to start off. Again, we're starting off with 1. What is my first term of my binomial? 2x. So it's going to be 2x to the 4th. What is my second term of my binomial? What kind of 3? It is -3 to the 0. The first term powers are decreasing. The second term powers are increasing. You hear me? All right. So we have +4, because that's the next. Yes. +4. And now we're at 2x to the 3rd, -3 to the 1. Those are your leading coefficients that you're starting off with. Yes. So we have 6. Now we're at 2x to the 2nd, -3 to the 2nd. Now we're on to +4. And that puts us at 2x to the 1, -3 to the 3rd. And then finally, +1. And that puts us at 2x to the 0, -3 to the 4. I'm putting everything in the pattern because if I don't, you're going to ask me, why is there no 0? So once you understand the pattern, you can minimize what you write on your paper. But for the sake of notes, I'm going to write out the full pattern. Okay, now you just multiply and simplify. All right. So in the first one, this doesn't matter. Why? Because it's just what? It's just 1, right? So now we have 2 to the 4th. 2 to the 4th is 4 times 4 is 16. X to the 4th. Yes? All right, on to the next. So now we have 4 times -3, which is going to give us -12 times 8 gives us -96. X to the 3rd. What's 2 to the 3rd, guys? 8. What's 4 times 8 is 32. 32 times -3. It just seemed easier to give you 12 versus 32. So that's why I went that way.
So we're at the
Minus 96.
It's -96. All right, next one. What is 2 squared? 4. What's 6 times 4? 24. What's -3 squared?
-9.
Negative times a negative is a positive. So what is 24 times 9? I can't do that.
Wait, what's 20? Wait, wait.
You can write it down, guys. No one's going to judge you.
216.
What do we get?
216.
216. And our power is x to the 2. Yep.
Wait, what happened to
So then.
What happened to what?
This equals 1, so this cancels out. Then you do -3 times the 3.
Yes.
Which numbers did you use to get those?
216?
Yeah.
So 216 comes from, I'm going to highlight it for you. 6 times 2 squared times -3 squared. What we get?
72x, just 72x.
It's not 72.
7. -27.
That's -7, the -3 and third.
And then times 1.
No.
189 or something.
No, not
So you have 4 times 2 is what? 8. And you're looking for 27 times -28. -20. I'm sorry.
Negative.
8 times -27.
8 times 2.
Oh. Okay.
Well, I
I guess I'll do it freehand. Hold on.
It's right here, guys.
Got it. Hold on. Hold on, I got it. No.
Oh.
We forgot to multiply.
Yeah. I know. I was wrong. I was thinking both and 9.
4 times 2 is 8. -3 to the 3rd. There we go. We made it. All right, on to the last one. This is going to be irrelevant, right? And we get -3, 80, what? 81. -3 to the 4th. You have -3 times -3 times -3 times -3. 9 times 9 is 81.
Oh my God.
I understand.
Like, huh?
Mm-hmm.
My equation? So I got, my coefficient said 3.5.
Ah. You gotta pay attention to the decrease in the powers. I mean, you said it, not me. So a type of problem that you may get is not, can you expand, but can you tell me what the term would be with x to the 5th? So it doesn't want you to fully expand, but could you? Yes. But do you have to? No. It just wants to know what would be your coefficient for x plus 3 to the 7th. We don't have to go all the way out. We just got to get to. Huh? I don't know. I hope so. Let me see. Yeah, I am. All right, so what could we do? Well, let's go look at the binomial theorem. Do y'all see this little binomial theorem up here? This would be, little. This would be our way of figuring out without having to do all of them. Does that make sense? But we would need to know where we're at. So Pascal's triangle helps us, but when it comes to like, oh, I don't want to go all the way down on Pascal's triangle, this is where the binomial theorem comes into play. Does that make sense? So here, in this case, our n would be 7, right? So we would have 7 over 0, 7 over 1, 7 over 2, and then we'd go from there without having to use Pascal's triangle. Does that make sense? All right. And so if we're looking for x to the 5th, well, this would be x to the 7th. This would be x to the 6th. This would be x to the 5th. So we would need to use 7 over 2 to figure out where we would be at. Does that make sense? So instead of having to continue with Pascal's triangle, we're going to use the binomial theorem here. Okay. So we'll start off with our first one. So we have 7, 0. And we have x to the 7th, 3 to the 0, correct? So instead of having to go back and say, oh man, I got to go all the way down on Pascal's triangle. No, you don't. That's where the binomial coefficient theorem comes from. Okay, now we're going to do 7 over 1, x to the 6, 3 to the 1. Are you still with me? Plus 7 over 2, x to the 5th, 3 to the 2nd. And this is what they're asking. So I don't have to go any further because they just asked me, when do you get to x to the 5th? And so I just have to evaluate here at x to the 5th. Make sense? The rest is irrelevant. I just have to stop here. Because that's all it asked for was what was the value at x to the 5th. The whole thing? No, a little more. We got to do the whole part. So 7 over 2, that means we have 7 factorial, 2 factorial, 5 factorial. Agree? Times 3 squared is what? 9, x to the 5th. So evaluating that is going to tell me what my coefficient would be. This is a multiplication symbol because we have to multiply them. 3 squared? Yes. All right. How do I evaluate the factorial?
7.
There we go. So we end up with 7 times 6 over 2 times 9, which equals what? I'm going to cancel out the 2, turn this into a 3. I'm lazy. I'm going to write it, my coefficient. Right there. What's 21 times 9? What's 21 times 9? 189. So we get 189 x to the 5th. I canceled out the 2 by dividing it by 6. 6 divided by 2. Dang it, I did this. Ooh. Didn't mean to do that. Figure. Yes. How do we feel? I know. Told you today was brand new. Brand new. Oh, I'm sorry. I'm sorry. Well, we learned something new today. Completely new.
I want. That's the statement.
Okay, how do we feel? Was it terrible?
Yes.
Yeah.
What made it terrible? Because it's new. That wasn't even long. I learned that we struggle with basic multiplication is what I learned. Yeah.
Oh, that's okay.
Okay, this is like, I swear to God, like, I'm being honest.
Yeah.
This, at first it was difficult,
Uh-huh.
but as we go through it, it's really not that bad.
It's really
I promise you, I'm not joking. I'm
Okay.
not making like.
I think
It's just gotta remember the little rules of first term powers are decreasing, second term powers are increasing, and then you just follow the pattern. If you don't have Pascal's triangle, then you're going to use the binomial coefficient rule. And that's it. That's it. That's all we got to do. Okay? Now, again, if for whatever reason you're like, I don't want to do this, could you have sat there and multiplied x plus 3 times 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 x plus 3 until you got to that?
Yes, but
You could have, but why would you do that to yourself? And you can't tell me that this is not shorter than doing that. Okay. Yeah. Yes. So the last one, it says in the expression 6,2, what coefficient does this represent on Pascal's triangle? Okay. So we're just asking what would be the value that it's representing in Pascal's triangle. And we just got to evaluate it and then say which value it would be. So, fudgesicles. So following Pascal's triangle, this is coefficient 1, coefficient 2, coefficient 3, right? So this would represent our third coefficient for our Pascal's triangle for that row. But we got to find it. It is. All right, here we go. Can we do this? We can't do this binomial expression. So it's going to be the third. So we're on, what do I get? What do I write? What does 6 over 2 tell me?
6 over 2. 4.
6 factorial
4.
over 4. Okay, now keep simplifying. What can cancel out?
The 4 and 6.
Not the 4.
The 4, 3, 2.
Okay, so we're left with 6, 5, and 2. What else can I do? Or just math it out. And what is that?
Equal 15.
15. So this is the third coefficient. Does that make sense? So this would be the third value in the Pascal's triangle for what row? Row 6. Why row 6, August? Because you wrote yours out. What is row 6? Because what is our end value? Our end value was what? It was 6. That's how we know what row we're on in Pascal's triangle. Because our end value is 6. You see that?
Wait, why would, hold on. Back it up. Wait a minute.
That's just a third
Fill our cup slow up. What is happening?
It asked us, what is the coefficient and what does it represent in Pascal's triangle? So backing up to Pascal's triangle, if we were to continue and go down, we have 1, 6, 15, 20, 15, and 1. And we found what? Which values? So what on row 6? 0, 1, 2, 3, 4, 5, 6.
Seventh row. But
It's row 6 of Pascal's triangle.
seventh.
Oh my gosh. How do we get? Remember you're adding?
Oh, I understand the whole triangle now.
Good.
Just now?
Yeah.
Yes. We'll take it, better late than never. Yes, I'll take it. All right. Yes.
Yes. Yeah.
Our first day of completely brand new material.
I understand this whole list.
How do we feel?
Feel confident. I feel like 5 out of 10.
All right. Yeah.
6 minus 2.